work issues. So.
Well, no, I didn't mean it like math friends.
Well, I mean, we're in the same department. I would guess we're friendly. I don't know.
Just wondering.
We friends? I mean, it's not like, huh? Co-workers? Yeah, I don't have many friends actually. I really don't want a lot of friends. I mean, it gets to be a problem. Well, I don't know if we want to get into that because, and I have problems lying, so I'll just skip that question. What were we talking about? Right. Please stop clicking that pen. All right. So now someone else can do it. Click, 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 click. There we go. There we go. Teaching in America. I can't get this thing to work. Okay, here we go. There we go. All right, there we go. We're ready. We're ready. We're ready. Did you know that this is, you should know that this is pi over 2. Remember when we did that little extrapolation? Sine of pi over 2 is 1, and then input, say it, output, and then we got to graph it. Then this was negative pi over 2. This is what this really means up there. You notice that these outputs are opposite of each other. One is 1 and the other one's negative 1. That's what this says up here, which is going to be an identity. And by the way, you're going to have these memorized. We're having a quiz Thursday. Mrs. Westberg's class, they taught us yesterday, fumble, and they had a quiz today, right? Didn't we just hear that? I'm going to add a couple things to mine, though, that they had. They just had to fill in the blank. You're actually going to know what the quiz is. I'm going to tell you what it is. This is going to be one of them. I'm going to ask sine of negative x, and you're going to have to tell me, what is that? Is that sine of x or negative sine of x? It's opposite. And that's what this says. So how does this work here, fumble? All right. You put a pi over 2 in here. The sine of negative pi over 2 is equal to the negative sine of positive pi over 2. They're opposites of each other. That's what odd means over the origin. But then look at cosine. This is crazy. It doesn't matter with cosine. I decided to pick this in the other class. This is pi on the x-axis. Oh, no. You know what that means? I get to be a lazy bum and go sit at my desk now because my battery's going to run out. Oh, my gosh. No comment. All right. And then this is negative pi over 2. Are you going to take the test too or no?
Yeah. For Thursday?
Sure. I could do that. Are you going to show up? All right.
I will.
What? Where were you for 9 minutes? We'll talk about that after, Ivo. All right.
I can tell you right now if you want. Right when I get off the office, there was this girl. She was like, "Well, do you know where my lunch is?" She was like, "Let me transfer." So I showed her like downstairs. She had to go all the way to the basement. He was being a good citizen.
I'll check the video cameras to make sure that that's not a lie.
Yeah, we should have talked to
Fumble. All right, here we go. Is everyone okay out there? All right. So cosine of pi, I forgot we were taping, is negative 1, and cosine of negative pi is negative 1. They are equal. So this happens anywhere. Cosine of 2 pi equals cosine of negative 2 pi. That's what this says here, right? That's called an even identity, or that's why they're even. And then one more time, this is pi over, by the way, what is this? Pi over what? That gets you 1. Pi over, anyone? No? No? Remember where the asymptote is? Here and here. So the period's pi, so where are the asymptotes at? Pi over, we just had this test, by the way, guys. We just had these questions. So those asymptotes are at pi over 2. So then what's this? Pi over 4. Oh, boy. All right. And then the tan of pi over 4 was 1. And then the tan of negative pi over 4 is negative 1. So they are opposites of each other. So this is the way I choose to kind of show the harder of the identities we're going to have to do today. But you didn't write this down. It's a big mess. I cut this from the book. And I cut this from the book, and it looks like a big mess. And guess what? Here's your quiz. Here's at least the first 5 questions. You'd have to fill in the blanks. And this is why this is not hard. And if it is hard, you haven't listened to me in chapter 1, chapter 2, chapter 3, and chapter 4. Because what is cotan of theta? 1 divided by, what is this reciprocal of cotan? 3, 2, 1, go. Oh, 1 over tan. I heard a couple people say it. Boom. 1 point. What's the reciprocal of secant? So secant of theta is equal to 1 over 3, 2, 1, go. 1 over. And if you get this wrong, this is all on you at this point. We've been talking about this since chapter 1, 2, 3. And then when we graphed cosine, when we graphed secant, we flipped cosine in order to graph secant. So we literally even talked about it last section. What's cosecant of theta? 3, 2, 1, go. 1 over sine. Don't say it's sine. You're going to get that wrong. Cosecant of theta does not equal sine of theta. Cosecant of theta equals 1 over sine theta. And then if you care to write these, of course, the flip of this or the reverse of this is true. So of these 6 questions, I think I asked 4. You know, that there's 4 points on Thursday's quiz. It's on you if you can't get those. And then I think we already wrote this before, but just humor me for a second. What's y over r? Which trig function is that? 3, 2, 1, go. Sine. What's x over r? 3, 2, 1, go. Cosine. I hope you do know the r's cancel, my fraction friends. And then what's y over x? What's y over x? Which trig function is that? Tan. There's the proof. Now notice what these are called. Reciprocal identities mean flip identities. Quotient identities mean write these in terms of sine cosine, like as a quotient. Sine, let's say sine and cosine. Write these in terms of sine and cosine. Okay, so look at this beginning, what tan became. Or remember, tan is y over x. Who has y in it? Sine or cosine? Who has y in it? Sine or cosine? 3, 2, 1, go. Sine. So what's tan? Sine over cosine or cosine over sine? Sine over cosine. So what does that make cotan in the quotient identity thing? Flip. So what does cotan become? Oh my gosh, 5th period, cosine over sine. 5 or 6 points already. I think it's out of 15 with what I have. I have something special planned. Something that incorporates tomorrow's stuff as well. Okay, and then here's the next one, which is all this scribble over here. And I'm actually going to ignore I'm going way over here, way over here. I'm just going to start with a blank slate. What theorem is this? I actually wear this shirt sometimes. Pythagorean Theorem. Remember my shirt where Pythagoras is fighting with, what's his name? E equals mc squared. E equals Einstein. They're fighting over the c squared. They're fighting over the c squared. Okay, very important shirt. But we don't have A, B, and C. We have like, and I'm going to choose quadrant 2, X, Y, and then R. By the way, you're going to be doing this again today. This Sir Kicks or Ticks memory and all this other stuff. Because I swear to God, if you don't have Sir Kicks or Ticks, you're in trouble. Isn't this the new incarnation then of the Pythagorean theorem? Right. Whatever you do to one side, say it. So I'm going to make a decision, a management decision, to divide by r squared, and this is going to be obnoxious. I'm going to really write this out mathematically with all the syntax that you're supposed to write. So I can do that as long as I do it to both sides. And then actually, this is the math syntax I'm going to do real quick. This is x over r squared is what that means. I can rewrite it like that. This is y over r. That wasn't the pen's fault. I didn't connect that. I like to blame the computer with all my woes. And then and then here, guess what? This is theta, so this is okay for me to do this. Actually, then theta prime, we could consider that but either or, what is x over r for theta? What trig function? 3, 2, 1, go. Cosine. So I'm allowed to replace x over r with cosine of theta. And then let me just finish this off. Mathematicians are lazy and they don't like that notation, so they write it like this, so they have to write 2 less parentheses. That's the truth. That's the only reason they do that, is because they don't want to write the parentheses. Not lying. All right, and then what's y over r? What's y over r? 3, 2, 1, go. And that's not the first time I did. We did evaluations this way before. This is what we had to do when we had to do sine squared. And then there you go. This is going to be one Pythagorean identity that you have to fill out. I'm literally going to have in the section, tell me the 3 Pythagorean identities, and you will literally have to write that down, or you will miss a point. Okay, and then I'll tell you at the end how this all synthesizes together. Okay, well, whatever you do to one side, say it. So what do you think I'm going to divide by now? Q, Z. No, what letter do you think you want to pick next? Y. Okay, Q, Z. You could. That'd be stupid. All right. Did he call me stupid? You want to divide by one of the letters that's involved in this Pythagorean theorem to see another incarnation with trig. Okay, so we're not doing that long drawn out thing. All you need to know is what's x over y. What trig function's x over y? 3, 2, 1. See, this is the thing though. 3, 2, 1, which one is it? Cotan. If you don't know that, that's chapter 1, that's chapter 2, that's chapter 3, and that's chapter 4. At some point, you better figure it out, or else you're doomed. What's r over y? 3, 2, 1, go. Cosecant. And there's another incarnation of a Pythagorean identity. Before I go back to my identity sheets, well, what else can I divide by? And then I'll tell you how you should do this when you go to the test, like what you should do. But let's divide by x squared all 3 parts. There goes that pen again. It just really... 4th hour, I had a little hissy fit over the pen. I wish I would have taped that one. What's x over x? Of course, squared is 1. What's y over x? Which trig function is that? Oh no. Ticks. It's not hard. You know, I don't know. It really shouldn't be that difficult. I always get worried. Do people get things wrong on purpose because they're just trying to, rage against the machine? Kind of like, I'm not doing that because of him. I just don't think this is tough. You don't have to use, it's really based on things that you already should know. And then what's r over x? 3, 2, 1, go. Secant. And then notice on these, the non-cos are together. Sine squared plus cosine squared equals 1. Then it's 1 plus tangent squared equals secant squared. And it's 1 plus cotangent squared equals cosecant squared, for those that are good at memorizing. But I'll tell you what you do on the test quiz Thursday. This is what you do. Okay. I remember he said to derive. So I don't remember them. Okay, x squared plus y squared equals r squared. And this is all you have to do. Watch. Divide both sides by r squared. And then all I have to do is look. I got this right here. Okay, so I divided by r squared. What's x over r, everybody? What's x over r? 3, 2, 1, go. Cosine. What's y over r, everyone? 3, 2, 1, go. Sine. What's r over r, everyone? 1. Cosine squared plus sine squared equals 1. And then cross it off. And then now divide by x squared. What's x squared over x squared, everybody? 1. What's y over x, everybody? Tangent squared equals r over x, which is secant squared. Cross it off and then divide by y squared. And the smart people, you're not supposed to say that, Mr. Stamulus. I'll see that work on their test, that they actually do this 3 times, and then they got all 3 of them in 3 points. X over y cotangent squared, y over y 1, r over y cosecant squared. And then you'll know what goes on what side, since it is the beginning stages of you having to write these down. So here we go. 1, 2, 3, possibly 4 out of this section. 2 out of that section, maybe more. Yeah, I guess if I said quotient identities and I could throw in the quotient, which means fraction. I could throw this in there as well. And what do we just say cosecant of theta is equal to? 1 over what? Sine. Or I might say in this section, right, in terms of sine and cosine might be a better set of directions. But I think that might be what I wrote right in that section, which I know is just like this over here. But the reciprocal identities are definitely the flip identities. You got to flip, and you better write 1 over, right, to get those. All right, and then the last ones I actually already covered. So the only thing I can tell you this for memorization is just remember cosine, it doesn't matter. And all the other ones, it does. That's my little trick on these. So remember I told you when I did cosine of 2 pi is equal to cosine of negative 2 pi. Cosine of pi does equal cosine of negative pi. So, those, it doesn't matter. All the other ones are odd. So those, it is opposite. Odd, opposite, opposites. And then the brothers, sisters carry along. Whew. Does it feel warmer in here, yes or no? Did it get stuffier? I'm starting to feel like a thickness in the air. And then I love this book. I told you I love this book. Be prepared for other forms, and this is not going to show up well, but this is often a problem. This will come into tomorrow's stuff. You won't so much see this today. Do be ready for reshuffling of sine squared plus cosine squared equals 1. And good, I get to stay lazy in my chair. So what do you think sine squared should equal? All I'm asking is, if this gets reshuffled, what would I have to do to get sine squared by itself? What would I have to do? Subtract cosine squared. So what does sine squared equal to? 1 minus cosine squared. Now this doesn't show up very well, so I have to verbalize this. Careful. What do you think cosine squared of theta minus 1 is? Wait. Cosine squared, well, let me, so you can see me. Cosine squared minus 1, cosine squared of theta minus 1 equals negative sine. Who said that? Nice. Negative sine squared. Boom. That's why I knew it shows up there. It's just a reshuffling. You can't have your mind blown off of that. It's just doing some adding and subtracting. Whatever you do to one side, say it. That's the only thing that's going on there. All right. And then there's another one. Of course, then cosine squared equals 1 minus sine squared if you subtract the sine squared. Hey, look at your identities. Raise your hand when you know what this is equal to. What's cosecant squared of theta minus cotan squared of theta? What does that equal? Just takes one little undo operation. Raise your hand. What's cosecant squared of theta minus cotan squared of theta? What would that equal? Yes, 1. And you're going to actually make that replacement in tomorrow. This is actually, if you see this, you get to replace that with the number 1. It's mind blowing. All right, and that's what this whole chapter is going to be about. Forgot to tell last hour, the whole chapter is like what's coming up is just substitution. When something equals something else, you get to substitute. So if you see this in a trigonometric expression, you instantly get to replace it with that because it's true. I forgot. This is a good time to do this. My emails. Do I have it here? Boom shakalaka. Remember going over this, huh? We missed the extrapolations if we didn't get any of these right. Look. And then again, this doesn't work out if you didn't put the little elbow grease into this and actually do this correctly. All right? What's sine of 30? What's sine of 30 degrees? What's sine of 30? What's sine of 30? Someone tell me. 3, 2, 1, go. 1/2. What's 1/2 squared? I can't write on this. What's 1/2 squared? 1/4. Well, then what's the cosine of 30? It can't be a half. It's the other one, which is root 3 over 2. When you square that, that becomes 3 over 4. What's 1 over 4 plus 3 over 4? Okay, then this one, I'm not going to bore you anymore. Just tell you. Leave it as 1 over root 2. It is root 2 over 2. But 1 over root 2 squared. 1 squared is 1. What's root 2 squared? 2. I almost said 4. You're right. I was like, wait, that's wrong. No, you're right. I'm wrong. And then what's root 2? 1 over root 2 squared again. 1 over 2. What's 1/2 plus 1/2? 1. And then notice, this is root 3 over 2 squared, and this is a half squared. Notice 1, 1, 1. That's because this is a Pythagorean identity. It doesn't matter what angle measure goes in there. You will always get 1. If you did this correctly, 1. This is 1 squared plus 0 squared. 1. 1. This is negative 1 squared, which is 1, plus 0 squared. 1. Is there any others? Boom. This is 0 squared plus 1 squared. That's what you should have had as work for those. So it doesn't matter. And then look at some of these other ones. Oh, yeah. This is the 1 plus tangent squared equals secant squared. You don't get 1, but what you do is get the same expression, same answer out of those two. You should be checking this. If you didn't do this, then that's what happens. You don't, you know, that's what happens when you know. It's amazing. I don't know if you know that, but when you don't do work, you stink at math. All right. Arr. There's the other one. And then there's the sine over cosine equals tangent. Here's some tougher ones if you did that. So sine over cosine of an angle, same angle measure, does equal the tan of that same angle measure. So that was the whole point of this worksheet. The point is lost if you don't know how to do these chapter 2, chapter 3 questions. That's actually chapter 3 because radians were in chapter 3 for sure. 1 plus tangent squared does equal secant squared. 1 plus tangent squared of pi over 3. Tangent of a 60 is root 3. You get 4. You get 4 out of this. 4 equals 4. So that's the idea of those identities. Perfect timing to cover. Can you get my mouse? I'm old and decrepit. My knee hurts. I have barely any steps left in this life of mine. Thank you. All right. Okay, and then there isn't much left. I don't want to. Don't look. Don't look. I'm just gonna cover this up. I should have covered this up before. Oh, I do believe we should have this down, and I think we could do this way. Sir, anyone? Sir, Kickser, anyone? Sir, Kickser, say it. Ticks. We could do this way and make this a chapter 1 because I think we need this again. Believe me, I know. You know, the things that we need to have ready for this chapter. Okay, because this is literally a chapter 1 question. It is. What they want you to do is use a Pythagorean identity. I don't think that's the best way to do this. I hate doing these this way. The only argument is then it maybe gets you to memorize those. I think we could do this a different way. We could always derive it super fast. We could derive the Pythagorean identities always by this quick method right here. Divide by r squared, divide by y squared, divide by x squared. All right, you can always get them. And then they're used in different manners. So I believe we can still remind ourselves of chapter 1 and use this as a review. By the way, what kind of trig have we done all year long? It starts with the C and there's 2 O's and I'm running out of time. C-O-O, what kind of trig is it? 3, 2, 1, go. Coordinate. What letter is this if this is tan? What letter is that? 3, 2, 1, go. Oh, for the love of dog. What letter is 5 if it's tan? Y. And then what's the second letter? X. Demand your cooperation. All right, so, okay, and then it literally says I'm in quadrant 2. So how do I find R? Through we just talked about this theorem, the Pythagorean theorem. By the way, don't get tricked on this. It's not 4. It's not 3, 4, 5. 4 cannot be the hypotenuse. So if you thought that was a 3, 4, 5 triple, you're wrong because it's in the wrong spots. Don't want to be mean on that. So you got to use the Pythagorean theorem to get root 34. And then what's secant? What's secant? Secant's related to Kickser, so what's secant? Oh my gosh, this is terrible. Noah, are you sleeping? R over X. The sound of my voice puts him to sleep immediately. What sine of theta? Noah, what's the answer? What letter over what letter? What sine? Y over R. Boom, 5 over root 34. And then these are annoying. Cotan of negative theta. Watch this because this is how your book starts. And I kind of roll through what the homework looks like. I'll do one more stupid one of these. And then cotan of negative theta actually equals negative cotan of theta, the opposite of it. That's that odd relationship. By the way, what happens with cotan compared to tan? You do what? Flip. but then you also have to take the opposite because of that silly little identity out in front of there. Okay, so you got to remember cotan of negative theta equals opposite of what cotan of theta should be. Tan of theta is negative 5 over 3. So this is negative 3 over 5, but now it's the opposite because of that identity. And they do have a lot of questions that are annoying like that in the book, but it really makes you exercise those identities. Okay? So I really think this is what we should do. And then this one, secant of theta is 11 over 4. By the way, we're secant positive. What quadrants? Think about it for a second, and then 5 seconds less. What quadrants is secant positive? Remember, wait, how do you guys look at it? You look at it this way. All right, so which quadrants? 5, 4, 3, 2, 1. 1 and 4. And then what does this mean about sine, which the word is right above it? Sine is, what quadrants is sine negative? Careful. So what are the two quadrants that sine's negative? 3, 2, 1, go. 3 and 4. What's the cross reference between these two? 4. Your angle has to be in quadrant 4. So you got to make sure you read the question. This is identical to a chapter 1 question. And then you draw it. And then it is an annoying Pythagorean identity because you get an awfully large number there. So it's 11 squared minus 4 squared, 121 minus 16, and then you get root 105. But since it's in quadrant 4, you got to choose the negative. All right, and then to do circics or ticks, I think that's good. Good things. Now that you know y is negative root 105, then those are the 6 trig functions. So they ask these again randomly. They really do want you to use the Pythagorean identities. I don't want you to. You can memorize those in a different way. You're going to have those memorized in this section. And then I'm just going to go ahead and show the calendar real quick. Maybe. There it is. And then these questions like 7 through 11, those are exactly what I just did, those last ones, coordinate plane trig. I think 25, 27, and 29, coordinate plane trig. All the rest of them, do not, remember when in tutoring, what did I yell at them? Do not look at your identities. You try to think about them and then fill out these questions. Those are about knowing the identities. And if you don't do that, you're causing your own demise, all right? Because eventually you're going to have those memorized anyway, or else points will be